In this video we'll look at scalar invariance, which is invariance in the intercepts. And I'll start by showing you this schematic and explaining in overall terms what we're going to do, and then we'll move over to Amos and execute the technical steps. So in order to set up your model for in scalar invariance testing, we'll have to perform these steps here on the left. For the loadings, we'll fix one loading for each construct to invariant value in both of the groups, and the intercept for the corresponding loading will set to equal across the groups. This is in order to achieve identification. For the latent means, that's the means of the latent constructs that the items are loading on, we'll fix it to 0 in the reference group only. For the latent variance, we'll fix it to unity, that's 1, in the reference group only. So the latent means and variances will be set free to vary in the non-reference group. Then we'll test for invariance of the intercepts. Now, after we've done that, we'll constrain all the intercepts and loadings that were found to be invariant, and we'll release the fixed loading and release the fixed intercept. And this is so that we can test also these intercepts for scalar invariance. The latent means and latent variances will still remain 0 and 1 in the reference group only. So let's move over to Amos and see how this looks. So here's my model, and we're right now looking at the reference group, and you can see how the latent means and variances are 0 and 1. And if I switch to the other group, you'll see that they are set free to vary. Now, you can see that we have a number of values here. This is set to 0.569, which is the value we derived from the metric invariance test. And the same for this one here and this one here. And these are, all three of them are values that were derived from our metric invariance. And these intercepts here are also set to be equal across groups to achieve identification. For the other loadings, here are set to be invariant, and that's because we're assuming metric invariance at this time. So we want to isolate the intercepts and see which of these intercepts are invariant and which are not. Alright, so I have set up a number of models here, and the first one we're going to test is the model where all the intercepts are constrained. So we have a model here that constrains all the intercepts to be equal across groups, and we're going to compare this model to the unconstrained model. So I'm going to run this. Alright, I need to load the data set first. Like this, and we'll run that. Click text output. We'll go to model comparison, assuming model unconstrained to be correct. And you can see here that the model all intercepts constrained compared to the unconstrained model, it has a significant p-value. That means that it's significantly different from the unconstrained model. And this means that it's hard for us to claim scalar invariance right off the bat for the entire model. So I also did a number of other models here for each of the constructs. So let's just go back here so that I can show you. Basically what I did was that I constructed one model here where only the safety intercepts are constrained. There's actually only 2 of them, and the reason for that is that one of them is already constrained here. And I did the same for mindfulness, and I did the same for absorptive. So that means that we're able to through looking at these models, we can locate the source of the scalar variance, see which construct that it relates to. So let's go back to our output, because these models are actually already run. So for safety, you can see it's not significantly different. So the scalar invariance probably holds for that item. For mindfulness, you can see that this is not significantly different from the unconstrained model, so that's probably not where the problem lies. But if you look at absorptive, you can see that absorptive is significantly different from the unconstrained model. So at this point, we can conclude that we probably have problems with scalar variance in the absorptive construct. So let's have a look more at that one. So what I've done here to test this is that I built a number of model for each of the different items here, so we can test each of them for invariance. And you can see each of these models only constrains one of them at a time. So let's see what our results say about those. So we go back to the output, model comparison, assuming the log constraint to be correct, and we can see here. So you can see here that for Q34 it's insignificant. This one is insignificant too. This is insignificant. But for Q38 and Q39, these are significantly different from the unconstrained model. So we probably don't have scalar invariance for 38 and 39. Now, at this point, we have assumed invariance for Q48, Q15, and Q35. And that is not necessarily the case, but this was constraints that we put in here for the sake of identification. So we are going to do a new model. So let me go back to the schematic. Now we're now going to constrain all the intercepts and the loadings that were found to be invariant. We're going to release the fixed loading and the fixed intercept for these three items. We're going to let the latent means and variances remain to 0 and 1 as before. So let's see how that model looks, and I have that model already prepared here. Here you can see that we have now released the items that were constrained in the earlier model, and we'll be able to test them again. So let's see how this model looks here. And we're again now going to look at Q38 and Q39, which were found to be invariant, and we're going to look at Q15 and Q35, which were constrained earlier. For safety, we do have a number of issues with metric invariance, and when preceding tests of invariance, of different types of measurement invariance does not hold up, it doesn't always make sense to go further and test for scalar invariance. So we'll be focusing on these constructs now. So let's run this model. Seems like I need to load up the construct here too. Now we should be able to run this model. Oh, I forgot to mention, another reason why we still have Q48 constrained here is that we need to have at least one of these constrained in order to achieve identification. So let's have a look at these results. So if we look at Q15 and Q35, which were constrained in the earlier model in order to achieve identification, we can see that for Q15 it's insignificant. It's not significantly different from the unconstrained model, so we can claim scalar invariance. However, Q35 is still below 0.05, so it's still significantly different. So for this one, scalar invariance does not hold. Now, if we look at the items now, which we could not claim scalar invariance for before, which is Q38 and Q39, we see that these have actually changed. So now they are insignificant, meaning that the models where 38 and 39 respectively are constrained to be equal, the intercepts. They're not significantly different from the unconstrained models. We can claim scalar invariance for these models. However, the real problem were actually due to Q15 and Q35. So this is the process that you go through in order to test for scalar invariance.